Section 3.2 is about solving systems of equations. This time we're going to use algebra to do that. There's two methods of using algebra. The first method is called the substitution method. And that's a method that involves solving one variable, and then that expression is substituted in the other equation. And let's see what that looks like. It first starts by taking the two equations and isolating one letter in one of the equations. In this particular example, it looks to me like the easiest one to isolate would be this x over here, because we'd like it to be positive, and we'd like it to be a 1x or a 1y. So I'm going to subtract the 2y from both sides and isolate this x. This is an important step in substitution. You have to have a letter that's isolated, because now we're saying that x equals all of this stuff. So I'm going to take all of that, and I'm going to substitute it in place of the x. Because we know that x equals 8 minus 2y, so that means in the second equation I'm going to replace x with 8 minus 2y. And that is substitution. So what I'm left with is an expression that only has y's in it, and I can solve that. I can put all the y's together, isolate the y's, and solve like I'm going to do right now. So we'll distribute. Half of 8 is 4, half of 2 is 1y, then minus y equals 18. So this is 4 minus 2y equals 18. Now we'll just solve for y by subtracting 4. I'm going to go up here and finish it. So negative 2y equals 14, and then we'll divide by negative 2. So you end up with y equals negative 7. Now that's only a partial solution because that's the y value. I need to now find what the x value is, and I do that by taking the y and plugging it into this equation over here and solving for x. So x equals 8 minus 2 times negative 7. Negative 7 times negative 2 is a positive 14, and 8 plus 14 is 22. So my x value is 22, my y value is negative 7. That creates an ordered pair of 22, negative 7. So if I were to graph this system of equations, if I were to put these on a graph and graph them, they would cross in one place, and this is where they would cross. Algebraic methods like substitution are a lot better than graphical methods sometimes because you don't have to worry about being neat when you graph, and you can just use algebra. Here's an example using substitution again. This time I'm going to let you pause the video, read through this, and I want you to see if you can figure out what the two unknowns are, the x and the y, and see if you can write two equations, and then I'll show you how to solve them. The problem asks me to find the number of gallons of gas that Matt bought at each gas station. So I'm going to say that x is the number of gallons that he bought at the first station, and y is the number of gallons he bought at the second station. Those are the two values we're trying to find out. Those are my two unknowns. Well, the price at the first station was $1.46. At the second station, it's $1.55. Now, he bought a total of 36.1 gallons. Now, a total means he took each one and added them up. So I think that makes up my first equation. X plus y equals 36.1, because the number of gallons at the first station plus the number at the second station equals the total gallons he bought. And total, he spent $54, so our second equation is going to have to be how much things are worth. So $1.46 per gallon at the first station plus $1.55 per gallon y at the second station, and that equals $54.29. So those are my two equations. We're going to continue to use substitution. Over here I'm going to isolate either the x or y. It doesn't matter. I'll isolate the y because we did x last time. So 36.1 minus x is what y is. So I'm going to take that and I'm going to plug that in for the y in the second equation. Now I'm going to solve. These are like terms that are on the same side, so I'm going to combine them. And I'm also at the same time going to subtract 55.955. Now I'm going to divide both sides by negative 0.09. And we find out that the number of gallons purchased at the first station was 18.5. And now the easiest way to find the number of gallons at the second station is take that x and substitute it back into the second equation. So because this is a real world problem, it's not necessarily an ordered pair. We would say first station is 18.5 gallons. And the second station, 17.6 gallons. The second algebraic method is called the elimination method. And that's a way of eliminating one of the variables by either using adding or subtracting. If you look at these two equations, I like to write them on top of each other when I do elimination, because I'm either going to add or subtract them to eliminate one of the letters. And if you look here, positive 2 and positive 2, if I subtract 2 and 2, I get a 0. So watch what happens. 4a minus 2a is 2a. You just subtract going down like you did in grade school. And 2b minus 2b is nothing. 15 minus 7 is 8. And now I've eliminated the b's. And I can solve for a. Divide both sides by 2. And I can easily say that a equals 4. Now I'm going to take that and plug it into one of the original equations. I like the second one because the numbers are smaller. So I'm going to plug the 4 in for the a, and then I'm going to solve for the b. It doesn't matter which one of the equations you choose. So subtracting 8, I'm going to have 2b equals negative 1. Dividing by 2, I'll get b equals negative 1/2. Now if you notice, we don't have x and y here. The way you write the solution or the ordered pair is in alphabetical. A comes before b, so the ordered pair is 4 and negative 1/2. Here's another example of elimination. Looking at the equations the way they are now, I could add 3 and 5 or negative 7 and 2, and I wouldn't eliminate either one of them. Or I could subtract, and they wouldn't go away. So in this case, addition and subtraction won't work. So what I'm going to do is I'm going to use multiplication to help me get numbers that I can eliminate. So first I'm going to take the top equation and I'm going to multiply it by 5, and the bottom equation and multiply it by 3. Let's see what that does. 5 times 3 is 15x, but then you got to do everything. 5 times negative 7 is negative 35y, and then 5 times negative 14 is negative 70. And then we'll do the same with the 3, distribute it. So 15x plus 6y, and then 3 times 45 is 135. So what I've created is I've created x values that now are the same and that can be subtracted. You could have done lots of different things. We could have multiplied the bottom by negative 3, and then we would have got a negative 15, and then we could have added. We could have done the top by 7, or excuse me, the top by 2 and the bottom by 7. There's lots of ways that we could have solved this. I just chose to do it this way. So 15 minus 15 is 0. Negative 35 minus 6 is negative 41. Negative 70 minus 135 is negative 205. And then we'll divide by negative 41. So y is going to equal 5, and then we take that 5 and we plug it back into one of the originals. I like the second one. So 5x plus 2 times 5 equals 45, and then we'll subtract 10. So 5x equals 35, and then finish off by isolating the x. X equals 7. Now even though we found the y first, when we write the answer, or the solution, we put them in alphabetical order. So the 7 comes first and then the 5. Last one, using elimination. If I add, I don't eliminate anything, and if I subtract, I don't eliminate. So I'm going to take the bottom equation and multiply it by 2. Now if you look, these numbers have coefficients that are opposites. 8 and negative 8, 2 and negative 2. So in this case I'm going to add. So 8 plus negative 8 is 0. 2 plus negative 2 is 0. So we get 0 equals 35. Now something interesting happens here. The letters all fall off. They completely go away. When they do, there are two potential solutions. And here's how you need to think about it. If all the variables cancel off, you're going to say all real numbers if the equation is true, and you're going to say no solution if the equation is false. So we go back up here. All the letters canceled off. So does 0 equal 35? No, it does not. So this is a false equation. So our answer is no solution.